Hey, welcome to Passages in Applied Mechanics by Dr. Lorenz Garcia. Today, statics, concurrent forces. When a structure or a machine component is at rest, it is said to be in static equilibrium. In general, the state of equilibrium can be defined as a state of rest or balance under the action of forces which counteract each other. If an object is at equilibrium, then the forces are balanced. Balanced is the key word that is used to describe equilibrium situations. Thus, the net force is zero and the acceleration is zero. In other words, objects at equilibrium must have an acceleration of zero. For example, consider a picture that hangs on a wall. The picture is in a state of equilibrium, and thus all the forces acting upon the picture must be balanced. That is, all horizontal components must add to 0 Newton and all vertical components must add to 0 Newton. Free body diagrams. When problems involving the equilibrium of bodies under the action of force systems are being solved, a method of setting out the essential details in the form of a diagram is necessary. We often with a semi-pictorial sketch or space diagram showing the physical conditions of the problem, for example, a layout of the mechanical or structural components such as pulleys, support, cables, rollers, etc. The next step is to isolate the essential facts about the forces involved and to draw a free body diagram. Such a diagram usually shows the point of concurrency acted upon by all forces, indicating the magnitudes and directions of the forces. Finally, a separate force polygon is then constructed, based on the information contained in the free body diagram. Free body diagrams are used by most engineering disciplines from biomechanics to structural engineering. It is an important step in understanding certain topics, such as statics, dynamics and other forms of applied mechanics. A system of forces is called concurrent when the lines of action of all forces intersect at a common point, the point of concurrency. See these examples. In the first one, we have a traffic light. Because the lines of action for the gravitational force and the two tension forces line up at a single point, these forces are considered concurrent. In the second one we have a table. Because the lines of action of the gravitational force and the two normal forces do not intersect at a single point, these forces are not considered concurrent. As we initially mentioned, for a system if concurrent forces in equilibrium, the resultant force, which is, the result of the summation of all forces acting through a point, must be equal to zero. In other words, all forces balance each other in such a way that there is no resultant push or pull acting on the body at the point of application of the forces. Mathematically, we have. This is usually expressed in terms of mutually perpendicular directions x and y, often horizontal and vertical as. Let's apply these concepts to solve engineering problems. Dr. Lorenz Garcia here, thanks for watching. Ciao.